in the today's session, what we will do, we will import the DXF in the ETAB. Okay, so let's go to the ETAB, and to import the center line in the ETAB, you have to go to the file, then import, then doc.dxf file of the floor plan. And then you have to choose the file, the DXF file, and you have to open it. So here we have to select the center line because so here we have choose center line because our center line layer is like our DXF, our center line layer is name is center line. Okay, that's why it's showing center line in the beam portion. Okay, so we have to take the beams in the beam section. We have to take the center line. Then here we have to choose the story one, and the DXF unit we will choose and here at the beam properties we will choose concrete beam, and the column properties we will choose concrete column, and the flow property should be slab one. Okay, and let's check the dimensions of the DXF. The dimension of the DXF is 1580. It is in mm, so that's why we have choose here. Okay, and we will click OK. Okay, fine. So let's copy this, add in this location, and there is an error in the DXF because you have to close the window first. Okay, that's why its error is coming. So what we can do, we can we will do again, like we have to go to the file, import .dxf file flow plan, and it's a G+3. We will open it, and we have to take the center line. Click the story one. DXF file should be and the beam property should be concrete beam, and it should be concrete column. It should be slab one, and we will click OK. And here we will name it as G+3 and 01. Okay, and save it. You can see we have successfully imported. You can see in the plan view there is a story one. Okay, and we have successfully imported the center line plan. So now we will start the ETABS analysis. So first we will define the material properties. To define the material properties, what we will do, we will go to the define section properties frame section. So first we will define the to define the material properties, we have to go to the define material properties and add new material. So the region should be India, material type should be concrete, and standard should be Indian, and grade should be M25, and we will click OK. And you have to check the density is 25. Okay, and the modulus elasticity should be 5000 into under root FCK, and poison ratio should be 0.2. Thermal expansion should be 1.3 into 10 to the power minus 5, and the shear modulus should be 10416.67 for M25. And you don't have to check everything, it is auto generated, and we have to click OK, and again add a material of M30 also, and again add a material of M40 also. And we have successfully added the concrete grade. Now we will add the steel grade again. So you have to go to the define section, material properties, and you will click add new, and in the material type section you have to select the rebar, and let's import HYSD grade 415. Okay, and now again we will import HYSD grade 500 also, and we will click OK. And we have successfully defined the material properties. Now we will define the section properties. First, we will define beam section. To define the beam section, we'll go to the define section property, frame section. We have to select the concrete beam, then add copy of property. And here we will write beam. So first we will check what is the beam size. It's 230 by, it's 230 by 450. And we will write material property also. It's M2 up M25. So we will select M25 here. It should be 230 and it should be 450. And at the reinforcement section we will modify it. And in the design type it should be beam. If we are assigning beam property, so at the design type it should be beam only. In the longitudinal bar we will select HYSD 500, and the confinement bar we will select HYSD 415. And okay. And okay. And we will also add okay, so we will add column property, column section. So we will select concrete column and add copy of property. Here we will add, there is in the framing there are two column. Okay, so there should be only two column actually. Okay, so beam is 230 by 450, and there are two columns C1 and C2. So we will, it's 300 by 450, or it should be 400 actually. And so we will write C1 300 by 450, and here we'll write 300 and it should be 450. Okay, and it should be M25, and we will write M25 here. And so the section is concrete rectangular section, and the reinforced section we'll modify it. So at the design type it should be column, and longitudinal bar should be HYSD 500, and confinement bar should be HYSD 415. So here the number of the longitudinal bar along third phase. So it's direction 3 and it's direction 2. So along third phase there are 3 reinforcement here. Number of the reinforcement. Okay. So along along third phase our dimension is 300. So if we put minimum center to center spacing of the reinforcement, if it is 100 mm, so the maximum we can place 3 bars only. So along second phase, if we take the minimum 100 mm spacing, so we only, so the number of bar along 2 should be 4. The minimum we can place 4 bar only. And okay. And okay. Now we will define the section property of the slab, and it should be okay. And to define the section property of slab, we will go to define section property slab section, and we will select slab 1, add copy of property, and here it should be S125. So here you can see the slab is 125 thick, and it should be M25, and here we will select M25, and here we will write M25 mm, and okay. It should be shell thin here, and okay. And we will delete this one and also delete this one and click OK. And we have successfully defined the section properties. Now we will assign the beam property. So here you can see all the beam sizes is 230 by 450, okay, and typical unless noted otherwise. So suppose we have like annotated the beam size here. It should, let's assume it's 230 by 500. So we will take 230 by 500 for this beam only, and for all other beam we will take 230 by 450. So in the in the flow in the framing here we have not annotated any beam size here. So let's take it to 30 by 450 for all the beam. So we'll select all the beam, okay, and we will go to the assign and frame section property, and we will select beam size and apply it. You can see, so you can see all the sections of the beam. You can see in the plan right now. Okay, if you go to the show undeformed shape, it will remove the tags from the beam. Okay, and so now we will draw the floors. To draw the floors, what you have to do, you have to select all the beams, and you have to go to the divide frames, and you have to break the all the frames at the joints, and you have to click the apply and OK. And now to draw the floors, what you have to do, you have to take the uh, draw rectangular floor, and you have to draw one rectangular slab here, and you have to select all the slabs in the beam, and you have to go to the divide shell, and you have to click the cookie cut and untick the extend frame and apply. You can see all the slabs are automatically placed in the ETABS, so you don't have to draw one by one. Okay, so that's how you can save the time. So if we click the this slab, you can see at the left bottom there is only one shell and four edges, and all the slabs are divided automatically as per our framing. So now we will draw the columns. So to draw the column, you have to select the draw column and select the size of the column. It is 300 by 450. Okay. So you can see the framing where the column is. You can see the orientation of the column is horizontal. So at the angle we have to write 90 degree. Now you can see the orientation of column is vertical. So we will place the column one by one here, looking at the framing. So here you can see we have to place the circular columns. So we have to add the circular column. To add the circular column, you have to go to the define section properties frame section, and add a copy of property. And here you have to select the circular column, concrete circle. And here we will write C2. It's 400 dia is there, and it's M25. And write 400. You have to write diameter here 400, and we will modify it. So here you can see the number of longitudinal bar is 8. So we will see what is the perimeter of the circle. Okay, so it's 2 pi r. So we will multiply 2 multiply by r, 2 pi. It's 3.14. It's r is 200. So this is a perimeter. We will divide it by 100. So if the center to center spacing is 100, so we can place 12 bars maximum. Okay, so we will write 12 here, and okay, and okay, and okay. So here we will place the circular bar. Okay, circular column. Sorry. So we have to select the circular column here C2, and we will place the circular column at these two locations. Okay. So as per the framing, we have placed all the column. So if you want to check whether you have placed all the column correctly or not, so what you can do. So first we will assign the slab section property. So to assign the slab sections, we will go to the select object type. We will select all the floors. We will assign the floors. We will assign the slab section. It's 125. You can see all the slab section is 125. Okay. So now, okay. So if you want to check the framing, the rather you have like doing everything right or not. So what you can do, you can go to the file, capture picture, current window as DXF, and save. And you have to open the current window as a DXF file, and Z space E space. So you can see, you can zoom out in the DXF. You can suppose you, let's delete this one, and you can copy this and you can paste here. Okay, so now you can check. You can overlap this. Move it. So you can overlap. There is, there is a column, yes, column, yes. You have placed a column here, yes, here also. Yeah, we have placed a rectangle, circular column also. Yeah. So we have done it all, everything correct. Okay. So we don't need to check again. So you can cross check everything you are doing. Okay. So now, so we have like assigned the beam, draw floors, and quick draw columns also. Okay, so we have assigned the beam properties. We draw like there is no wall, so we won't draw the walls. So we have drawn the floors. We have like quick draw the column also. And now we will assign the load pattern. To assign the load pattern, you have to go to the define load pattern, and here we will write self weight. It should be dead, and self multiply factor for self weight, it should be 1, and we'll modify it. And second one will be finish service sunken and wall. So it's finish. It should be dead and multiplier should be 0. Okay, for a live finish. It should be dead for finish, and we will modify it. Okay, now finish service. Okay, it should be 0, I think. Okay, it should be 0 and add new, and here it should be 0. So we will modify this. Okay, so it's service. Now sunken. We'll add a new load. Now it should be wall. We'll add a new load. Okay, and now here is a live less than 3. We'll add a new load, and for live we have to select the live here, and we'll add a new load, and for greater than 3 we'll add a new load. So it should be a reducible live actually. Modify and modify, and we will add EQX. So in the load section, EQX, it should be type should be seismic, and auto lateral load. Okay, so we will select the code that is 1893016, and we will add a new load. Okay, and it should be EQY seismic and same, and EQZ, and add new load. So the EQZ is a vertical earthquake. We will only take the vertical earthquake into consideration. We will take into consideration only when our building is located in zone 4 or zone 5. So this building is located in Delhi, and Delhi it is in zone 5. So that's we will take it earthquake, vertical earthquake. Okay, and now we will take wind load. And for the wind load, the code should be, the type should be wind, and the code should be 875 2015, and add a new. And in the Y section, we will add a new, and okay. So we have successfully assigned the load pattern. Now we will assign the P delta. For that, in the P delta, for the dead load, the factor should be 1.5, and for live load it should be 0.5. So we'll go to the define p delta. We will select the iterative base load, and for dead load should be 1.2. Add finish add service sunken and wall. And for live load it should be 0.5. We'll add it, and we will add it. Okay, what? Okay, fine. And okay, so we have assigned the p delta also. We will assign the mass source again. So to assign the mass source, we'll go to the define, and we'll go to the mass source. We will add a copy of mass source. Okay, and here we will write dead load plus live load, and we will add vertical earthquake also. So our building is zone 4 or zone 5. So we will include the vertical mass here. If our building is not in zone 4 or zone 5, it is in zone 2 or zone 3 only. So we won't include the vertical mass source. And the factor for the dead load it's 1, and for live load less than it's 0.25, and for greater than 3 it's 0.5. Okay, so we will add here dead load is 1. The 25%, and it's 0.5, it's 50% here. Okay, and we'll include the vertical mass source and click OK, and we will delete this one. Okay, here we will take this and we will delete this one. So in the default mass source section it should be dead load plus live load and vertical. It's, please make sure it should be done here. And now we will assign the floor load, and for the floor dead load what we will do, yes. Hello, yes, Anupama.
Hello.
You were asking something.
Yeah, the column part actually.
Which part?
So this longitudinal and vertical part calculation actually what you did.
Calculation, which calculation?
The calculator that number of hours,
Number of?
number of bars.
Okay, number of bars. Okay, 1 minute. Mhm. So for the rectangular one or a circular one?
For rectangular.
Okay, okay. So number of bar, let me give you the brief about it. Okay, give me some time. Okay.
Okay.
So okay, so this is our column, okay, and this is 300 here, and this is 400, okay. So suppose our minimum center to center spacing is this one, is 100 only, okay. Minimum you can go to the 100, and at least you can go to 90, okay. So what we are doing, so to calculate the number of bar, we are taking it 100 only, okay. We are taking it 100 and we are taking it 300, okay. Suppose the width is 300 and we are dividing it by 300 divided by 100, okay. So it will be 3. To calculate the rainfall, it's a hand rule method, okay. So we will along the third direction we will place three reinforcement here, but in the along the second direction, so our section is 450 only, okay. Here it should be, it's 450, okay, not 400. So along the second phase, so we will divide it 450 by 5, so it will come around, it will come around 90, okay. And after, the cover will be there, cover also will be there, so we have to minus the cover also from both the side.
It will be 450 divided by 100, I guess. Not
Okay,
5.
okay. Yeah. Okay, fine. One minute. Yes, yes. No, I was like calculating the center to center spacing. Yeah, you can also calculate like this also, like 100, okay. 450 divided by 100, it will be, it will be 4.5, okay. So we can maximum provide four spacing, no, four number of bars, okay. We can't provide like 5 because our spacing will be less than, I think it will be 85 around it. So what we can do, so why we are not like taking 5, because it it will be difficult to compact the concrete, okay. So suppose we are using needle vibrator, so needle vibrator diameter is almost 90 mm or 80 mm, okay. So we can't put put the needle vibrator between the reinforcement, okay. So we have to take it around 100 mm. It should be around 95 90 to 100 mm, okay. So minimum spacing should be that only. I think you know about this, like needle vibrator we use at the site, right?
Yes.
Yeah, okay. So for the circular also, for the circular bar also, we will calculate the calculate the circumference. Circumference is 2 pi r, okay, and the r is only 200, okay, and the dia is 400. So we will calculate the circumference and we will divide it by 100 mm. So we can take, so we will get the number of bars, okay. So let's go to the presentation. So here we have assigned the mass source. Here we have assigned the P delta. We assigned the load pattern also. Now we will assign the floor load. Okay. So what I have done, I have created Excels for the automation of the calculation of the floor loads. Okay. So let's go to the, so it's a dead load calculation Excel. I have the Excel for that. Okay. So it's a super dead load calculation using 875 part 1. So first we will calculate the flow finish load for the general floor slabs. Okay, now we will after that we'll calculate for the terrace slab. So dead load will be different for the terrace slab, and for the sunken slab it's also different, and for the staircase slab also it's different. Okay, so go to the let's go to our AutoCAD drawing. So here you can see the flow finish is 50 mm. Okay, so I think I have to open the dead load. This one, super dead load. So we will do the dead load calculations for the general floor slab. Here you can see we will take the 50 mm flow finish, okay, and the thickness of the and the density of the mortar will 21, and it's 21 kilonewton per meter cube, and we will multiply it with 50 mm, okay, and 50 mm. 1 minute.
Hello.
Yes. Hello. Am I
Hello.
audible? Hello. 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 Can you hear me?
Audible. Not audible.
Yes. So the flow finish thickness is 50 mm and the cement mortar unit weight is 21. So we will multiply the unit weight with the thickness of the flow finish. We will get the total load on our slab. Okay, and then we will take 6 mm thickness weight of the ceiling plaster also, and then we will take 12.5 mm thickness of the clay floors also, and we will add all the load and we will take it 1.5. So you can take a maximum of the calculated load. So what you will do, you will do the conventional design. So so you can see this is if this is a slab, okay. Suppose this slab is 125 mm. Okay, above this there will be a 50 mm of floor finish. It is a cement material. Okay, so it's a cement mortar material. And below this there will be a ceiling plaster of 6 mm. Okay, and it's also of mortar. Okay, it's also of cement mortar. So that's why we are taking it 21 density. Okay, and this is a thickness only. And above the floor finish there will be a tile of 12.5 mm thickness, or it can vary by contractor to contractor or architect to architect. So you can use any clay floor tile, or you can take the weight of that. Okay, you can calculate the weight of that. So we will add all the weight, that is floor finish weight, tiles weight, and 6 mm plaster thickness weight we will add on the slab. Okay, so so it's 1.3, so we will take it 1.5. So what you can do, you can take always, you can take, like, if it is 1.3, so you can take 1.4 or 1.5. Okay, you we will do the conventional design every time. We will do the conventional design to increase. We can increase the load, or you can take 1.3 also if you want. So here you can see, like I have prepared the Excel for the automation of the calculation of the load. You can see the thickness is 50. The flow If the flow finish thickness is suppose 100 mm, so it will give you the load of 2.35. So in our case it is 50 mm. So just give the input to the Excel 50 mm only, and it will calculate automatically. Okay, so it's 1.3. So let's take it 1.3. Flow finish load. Okay, so I'm telling you the general slab is, it's other than staircase slab and terrace floor slabs. Okay, so let's come here. Okay, and what you can do, you can remove the grids, and you can remove this one also, and this also, and you can simply copy this. You can move it from here to here. So here you can see this is a bedroom. This is a living dining kitchen room. Kitchen is there. A living dining room is there. Bedroom is there. Okay, and it's a toilet is here. There is a balcony. It's a lobby, and it's a staircase. Okay, this is a staircase slab here. Mm, so so what we will do? We will select every slab, and we will deselect the staircase slab here. You can see this is a staircase slab. We will deselect it. So now we will assign the dead load for the shells. So you have to go to the assign shell load uniform, and you have to take finish here, and you have to take its 1.5 and apply. So you can see every tag is there for the finish load. Okay, you can, if you go to the uh, show undeformed shape, the tag will be removed. And so for the terrace slab, we will assign the dead load to the terrace slab after adding the terrace slab in our model. So now we will calculate for the sunken slab. So you can see in the drawing, there is above the toilet there is a sunken. Okay, there is sunken. It's not the sunken is not at the terrace floor. Okay, it's not at the ground floor also. It is at the like at the middle floors only. Okay, so you can see this is sunken area above the above the toilet area. So let's calculate. Let's draw the dimension for that. Okay, what is the dimension of the sunken area? So it's 450. Okay, So we have to go to the Excel for that calculation. For the sunken slab, the thickness is 450. We have to give the input to the Excel for the sunken area. It's 450 only, and the weight of the sunken material, it will be automatically calculated by Excel. So here you can see for the sunken slab. So the cinder material we will use in the sunken slab. This is a filling material, and its density is 8 only. Okay, 8, and it's a cinder material. So generally it is 250, but in our case it's 450. Okay. So we have already added the weight of the cement mortar. Right. Okay. So we have already added the cement mortar weight and clay tiles floor. Okay, load. We have already taken that. So now what we will do, for the toilet slabs, we will assign the additional sunken load. So we will go to the E tab, and here you can see in the drawing. So these slabs are the toilet slabs. Okay, below that there is a toilet area. Okay, so we will select only these two slabs, and we'll go to the assign shell load uniform and sunken, and we will add it. I think it's 3.6. So we will add the 3.6, and we will apply it. And if you click on the show and deform shape, the tag will be removed. So now for the staircase, okay. So in our drawing, there is no staircase area shown in the drawing. So for the residential, the tread size is 150. The rise is 150 and tread is 300. So these are steps. Okay, these are steps, and this is a slab. And above the slab there will be a finish also. Okay, so this is rise, this is tread. Okay, this is a 50 flow finish every time, and it's 125. So here we have so the 50 flow finish we will take, and we will also consider the clay 4 tiles load also. So just give the input to the Excel, what is the rise and what is tread and what is the flow finish thickness, and you will get the load. So it's 3.05, so we will take it 3.1. So we'll select the staircase slab, and we'll go to the assign shell load uniform. We will take it as a 3.1 and apply. Okay, 1 minute. Okay, in the flow finish we will apply. Okay, so what you have to do, if you applied in the sunken portion, so you have to delete the load. Okay, and now again select the staircase. In the finish section you have to apply the load, and okay. So now what we will do, we will okay, we add it after some time. Okay, so we have assigned the flow finish load, sunken load. So in G+3 there is no lift machine, so we won't add lift machine load. So there is a water head, overhead water tank is there. So we will calculate the load for the overhead water tank. We will calculate the capacity first, and then we will assign the load to the overhead water tank slab. So now we will assign the live load. Okay, to assign the live load for the residential, so you have to first open the code, that is 875 part 2. Okay, I think I have given you all the Indian code, access to the Indian code. Like I have sent you the Google Drive link, so you can go to the Google Drive link and you can have the access to all the code. Okay, just you have to search it 875, and you have to open the 875 part 2. So here you can see for the residential building. For the residential building, there are, so all the live load is written for the all rooms and kitchens, toilet and bathrooms, corridors, passage, staircase, including escapes and storerooms, balconies. Okay, so for every room type, there is a live load is there. Okay, so you just have to. So let's go to here. Okay, so and we will open the ETAB. So you can see this is bedroom. So all rooms and kitchen. So bedroom is in, I think all rooms is there. Okay, bedroom is in all room category. Okay, so we will select the bedroom here at the both the sides. Okay, and now it's kitchen also, and there is a toilet also, kitchen also, and so living and dining room also, and we will left the lobby, staircase area, and balcony area. Okay, and this, so what we will do now, so it's 2. Okay, so we will assign live load 2. We will go to the assign shell load uniform, and we will select the live less than 3, and we will take it 2, and we will apply it. Okay, and you can see for the balcony and for the staircase and the lobby and the passage area, corridor area, it's 3. So we will select the staircase, lobby, okay, and balcony. These are the balconies, and we will assign it 3. So if the live load is greater than 3, so you have to select the live greater than 3. If live load is 3 or less than 3, you have to select the live less than 3 and apply. Okay. So now we will assign the wall load. Okay, so now we will assign the wall load. So before assigning the wall load, what we will do? So we will assign the overhead water tank load, or we will assign the I think so terrace floor loads also we have to assign. So to add the additional floors, what we will do, we will go to the edit stories and grid system, modify the story data. So here you can see we have to calculate the number of story first. So in the section you have to this is a ground floor, this is a plinth level, and it's a one, then two, three, four, five. Five floor is there, and there is a mumty also. So six floor we have to add. So there are only four floor is there. So you have to add it again. Okay, and it's a five, and it's six. Okay, so we have added six floor. First is plinth, and you can say it's ground floor. It's first floor. It's second floor. It's third floor. It's fourth floor. No, there is no fourth floor. Okay, I think there is a terrace after third floor. After third floor, there is a terrace floor level. So we will go to the R ETAB, and it's I think it's terrace. and it's Mumty again. What happened to the size? Okay. So this is a base, okay, and this is plinth. So from base to plinth, always take it's 2 meter. It should be 2 meter. Okay, minimum it should be 2 meter because uh, at the base there will be a foundation. Okay, so the at least we take 2 meter. You can take more than 2 meter, but you can't take less than 2 meter. Okay, always take minimum. You have to take 2 meter from base to plinth level. So it should be two here, and from plinth level, from you can say from ground floor level to first floor it is 3.15, 3.15, 3.15, then 3.1. So it's 3.15, 3.15, 3.15, and 3.1 is there. Okay, and for Mumty level it is 3.2. And okay, and okay. So our plan it is in plinth level G ground floor. Okay, so now what we will do, we will select everything, and we will go to the edit, replicate, and we'll go to the story, and up to ground floor, up to terrace we will replicate the plinth level framing area. Okay, so in the 3D section you can see we have replicate everything up to the terrace floor. So above the terrace floor there will be a multi level, so you can see the plan of the terrace floor here, and you can see the different plan for each story. Okay, for the ground floor and for the second floor, third floor, it's same. And for terrace floor, you can see this is a Mumty area. Okay, so we will add the Mumty area. So we will go to the plan terrace and we'll apply it, and we will select this area, and we will replicate the area at Mumty level. You just have to make sure that you have only selected one story here, and go to the replicate, and we'll go to the story, and we will apply the Mumty here, and okay. So you can see we have added the Mumty area also. So now what we will do, we will apply the terrace floors, dead load at the terrace floor slab, and live load also we have to change. So you can see we will take the waterproofing load, okay, and the ceiling plaster, and we will consider the clay tiles floor load also, okay. So you can see, so the thickness of the waterproofing is 125. Okay, so you have to consult with the architect what is the thickness of the waterproofing we have to provide, and so you can calculate the load. I think that is 3. So you have to go to the terrace floor. Just make sure there is only one story here, and you have to select the all the slabs at the terrace floor, and you have to assign the shell load uniform, and in the finish you can you have to replace the existing load from I think we will apply 3. Okay, we can see at the all the terrace floor slabs. Now we have assigned the 3 dead load, and for the live load, okay, so you can see here. So the live load for the terrace roof, it's 1.5. Okay, so we will assign 1.5 here. Don't select the staircase slab. Okay, I think you can select the staircase slab. Okay, don't select the staircase slab, and we will assign live load less than, it should be 1.5 here, and apply and okay. So you can see, so for the terrace slab, so the finish is 3 and the live is less than live less than 3, it's 1.5. And for the staircase slab, it is 3 and 3. Okay, and now we will go to the Mumty area. Mumty, you can say its finish is 3.1 and live is less than 3. Live is 3. Okay, it's also 3. So at the Mumty area, we will remove the live load, because at the Mumty area it should be 1.5. So we will go to the assign shell shell load uniform. It should be 1.5 and apply it. Okay, and so the above the Mumty level, we will assign one more slab for overhead water tank load. We'll go to the edit story and modify, and we will add one story and name it as overhead water tank. Okay, and let's take it 2 meter, and okay, and okay. So now we have assigned, you can see we have assigned the overhead water tank slab here. So we'll calculate the load for that. So I think you have this PDF. You can see the calculation here for overhead water tank load. So the number of floor is 6. Okay, so in our case the number of floor is 4 only. So we will select 4 here. Okay. So number of person on the each floor. So you can see it's 2 BHK at the each side. So suppose four persons lives in 2 BHK. So for one floor it is 8 person will live. Okay. So I think we have to put 8 here, and then so it will automatically calculate the total number of passenger. So for the liter per capita demand, it's 135 for one person. So we'll multiply it 135 by 32. So we will take so we will get 4320. Okay. So let's consider 2 days of storage, and now the volume in the liter we got 8640. So we will so 8640, we will divide it by 1000, so we'll get in meter cube. So now it's 8.64. So it's 8.64. Now we will multiply it by 9.81, that is density of water. Okay, here you can see we have multiplied by 9.81. So it's in meter cube. Okay, you can see it's in liter and now it's in meter cube. So 2 days of storage we have taken. Okay, so 135, it's a demand for one person. So we have multiplied with the number of persons, so we get the total demand. So you can see that for the each person, and we will divide it and then multiply with the 6. Okay, so we got the total, and it's 135 demand as per the UDPFI. Okay, so total mass of water is 254.27. So now we got the total mass in kilonewton, and we will divide it by the area of the tank. So area of the tank will always be on the over the staircase slab. Okay, So you have to uh, draw the dimensions for the staircase slab. So let's do it in the E tab. So this is a staircase slab. So the overhead water tank will always be on the, so Mumty level will always be on the staircase slab, and the overhead water tank will be always on the Mumty slab. So what you can do, you can draw the dimension line. So let's draw the dimension line. It's 4.8 and it's 3.53. So you can so let's go to the option and graphic preference, and let's put 12 here and 12 here, and okay. So now you can see it's 4.8 and it's 3.53. So what we will do, we will calculate the area of the terrace staircase slab. So it's 4.8 multiplied by 3.53. So we get 16.944. So we will put 16.9 here as the total area of the water tank. Okay, now we got the dead load per area is 5. Okay, so we will go to the overhead water tank level. Okay, so just make sure it's one story, or we will delete this area here from here. Okay, delete, we'll delete it, we'll delete this, delete. So this is the water tank area. So we will select the slab, we will go to the assign, we will go to the shell load uniform, and we will select the service here. So in the service section we have to assign the water load. Water load is 5. So we will select 5 and we will apply it. Okay, so let's right click here. You can see here finish is 3.1. Okay, and the live load is 1.5 and service is 5. So for the water tank load, the live load is only 0.75 here. You can see. So it's a slab with access not provided and for the maintenance purpose only. So for the maintenance purpose, the live load will be 0.75 only. So let's assign this 0.75. Go to the, and for the live less than 3, 0.75. And now you can see the finish is 3.5, live is 0.75, the service is 5 only. You can see this slab, the terrace slab, it's at the first floor plan only. Okay, not at the second floor and not at the terrace. So what we have to do, we have to delete it. So we have to go to the terrace, apply, and we will select this area. Please make sure there is one story, and we will delete this from the terrace, and we will move down list, and we will delete this from third floor, and we will delete this from second floor also. And you can see there is this slab is at the first floor and at the ground floor. So you can see there is no basement in this building. Okay, so what we have to do, we don't have to take slabs at the ground floor level, because ground floor slab will be built on the earth. So this the ground floor slabs load will transfer to the earth only, not to the framing. So we will delete every slab from the. So what you can do, you can select this object type floor, select the floor, and you can show selected object only, and you can delete every slab from the ground floor. Show all. Okay, so here you can see this is a balcony. It's a balcony area. So you have to. So at the ground floor there won't be any balcony. Okay, so you have to delete it. So now it's perfect. So we have assigned the overhead water tank load, okay. So we have assigned the live load also. So now we will assign the wall load on the beam.